All right, you said you could all hear me, so good morning. I am going to start up, and very quickly, you've seen this before many times, but just so you know, we are pretty much on track from the new revised schedule. And that is, we're going to go over Chapter 7 today, and yes, there will be time. We will go over selected problems, and I just sent that to you just a couple minutes ago, literally hot off the press. Then tomorrow morning, I've got lab all period, but I put an exclamation point there because of the fact that, again, what I plan on doing with you is I'm going to go over these 4 examples that you see right here. Morning, John. Can you hear me?
Yeah, I can hear you.
Okay. So again, what I just mentioned was this is today. Tomorrow it will be lab, but in lieu of you doing any of the homework, I'm going to go over all 4 of these problems tomorrow. I want to make sure you're really, really prepared, all right, for the test that we'll have next week, all right? So next Monday will be lab the entire period. I will start up a team session at 8:05, and if it's dead air for 3 hours and 50 minutes, that's totally fine. I have no problem with that at all. Tuesday again will be the pretest where I will, by 8 o'clock on Tuesday, I will have emailed you an electronic copy of the pretest. Then from 10 o'clock, until, 10 o'clock till the end of the period, I'll go over and do the pretest for you. And next Wednesday will be the hands-on test. All right, so that said, I'm going to go after this or at this a little bit differently. This chapter is broken up into basically 2 sections. Forget about this future value app. But they talk about exceptions and exception handling, and then they talk about data validation. So the reason I'm going at this a little bit differently is I want to explain a couple things to you as we get started. Now, right before class, I sent you an email. The email has in it 2 different things. It's got like about 3 or 4 URLs in it. And then I went back and I've been making some changes to these calculator and MPG programs. So you've got everything. I was going to have us do it, but I'll tell you what, the last thing I was working on, I spent almost an hour on it. And I want to make sure that, again, you understand everything that's going on. So as an introduction to exceptions and exception handling, I'm going to first go out here. All right. And where I am right here, just so you see, I believe it's the first URL that I gave you in there, but just in case, I'm going to show it to you. It's right here. Do you have to go out there? Of course not. But I just want to show you, it is under tutorialsteacher.com/C# exception. If you go out there, you will see, amongst other things, this. All right. So what I want to tell you, because it's a little bit hard when you first see it to understand, what you have in front of you here, this picture, for lack of better words, is a hierarchy. It is a hierarchical diagram. All right. So at the very top, so at the root, so to speak, is object. So object is the grand poobah. It's the parent of everything, whatever way you want to look at it. Everything is of type object. Well, there's, controls, etc., are of type object, but today we're only talking about exceptions. All right. And in particular, different types of system exceptions. All right. And really, and sorry, Michael, especially for you, if you've heard this already, but I did talk about exception handling last semester in the AWD1100 class, the Web Development Technologies, which John, I guess you'll take in fall of next year. And I mentioned in there that there's basically 3 ways, there's probably more than that, but there's basically 3 ways to handle exceptions. All right. The first way is what I call the Ostrich Method. And what I mean is you don't do anything. You just suppose that the person running the program, if you ask them for numbers, for example, they'll only give you numbers. And if you ask them only for something special, that's all they give you. As you'd probably guess, that's probably the very worst way of doing something. Because once you go and you put the honest, so to speak, on the end user, all right, sooner or later, either purposely or accidentally, the end user is going to make a mistake. It's just human nature. We all do it. So again, that's the worst way. The second way to handle exceptions is the way we basically have been doing it so far. And that is, we've been using if statements. And we are not even letting bad data into the system. If we see that there's something wrong, we've either been doing something like yesterday, I went in and set default values for gallons used and miles driven, or we give them an error message and put it into a loop and have them do it again. Now, many people will argue that that's the best way to handle error handling, all right, or exception handling. And the reason for that, they think that that's the best, is you're not letting bad data into the system to begin with, all right? Now, on the other hand, the way that we're talking about today, using standard exception handling lets bad data into the system, but then deals with it. So that's kind of the difference between them. All right. And I'm not saying, hey, does that make sense or does that not make sense? It may make sense. It may not make sense to you. Hopefully, it'll make a little bit more sense once we get going and we start talking about the stuff that's in here. So this would be level 0, level 1. This would be level 2, etc. And you can kind of see what's happening. Well, normally when you talk about exceptions, normally the ones you talk about are the ones that are shown here. These are the built-in exception classes. Now, it might be a little hard to read. I'm going to make this bigger so we can see it and go through it. There are examples of these if you click the links. I'm not going to do that right now. The first one says argument exception, and it says raised when a non-null argument that is passed to a method is invalid. What does that mean? That means that, for example, you're expecting a number and you pass in a string, something like that. So there is a mismatch between yesterday, what I call the actual parameter, and what's in the method and what I call the formal parameter. All right, so that's the first type. Then you've got an argument null exception, and as it says, it's raised when a null argument is passed to a method. Well, typically that's not going to happen. But for instance, if I'm expecting a number and what I get instead is null, that's the kind of exception. The ones that we're going to look at more today are going to be, for example, the next one here, argument out of range exception. Raised when the value of an argument is outside of the range of valid values. Now, I'm going to tell you something quickly, and you're all smart enough to realize this. If I'm writing a miles per gallon program, and I put in there -36 for the number of miles I've driven, and -2 for the number of gallons I used, it'll divide a negative by a negative, and it'll give me 18. All right? Now, how do I get over that? Well, yesterday, the way that we did that was we made constants. And we had a minimum constant for minimum miles and a maximum constant for maximum miles. All right. And then we checked that, and we checked that within an if statement, which is totally fine. We're going to do that again today. But what you're going to see when we start to go through these examples is instead of just giving an error, et cetera, and instead we are going to throw an argument out of range exception. All right. Then we're going to go or before that, we'll look at the calculator problem. And if you remember, we don't want to, if you pick either divide or you pick modulo, we don't want to let you divide by 0. So if we attempt to, what is that? The numerator, and I think it's the denominator, the bottom one in the divide. If that one is 0, we're going to throw a divide by 0 exception. All right. So again, I'm just trying to give you some context to what we'll be working with. All right, we're not going to look at the file not found because we haven't worked with files yet, but that would be in the case where I try to open up a file to do some processing and the file doesn't exist, and it could exist because literally it doesn't exist, or I could have given it the wrong path, or I might not have permission to use it. So there's a bunch of reasons that could happen. All right, we are going to look at format exceptions. All right, and again, we'll get to that in just a little bit, but it says it's raised when a value is not in an appropriate format. Well, what does that mean? Yesterday, what we did was we tried to do a try parse, and if it failed, so we did an if not result, then we gave our error messages. Today, if that doesn't work, we're going to throw a format exception. All right. Now, in the next chapter, in chapter 8, not 7 that we're on now, but in chapter 8, we're going to talk about arrays. I don't want to get into arrays right now because I got plenty of time to go over that in the next couple weeks. But when you work with arrays and you want to access the elements that are in an array, they start with 0. So let's assume I had an array with 2 names in it, Jones and Smith. So Jones would be the array element 0 and Smith would be the array element 1. If I tried to reference array element 2, which does not exist, I'd get an index out of range exception. So again, you'll see that soon. All right. The invalid operation, it says when a method call is invalid in an object's current state, that'll probably make more sense when we talk about object-oriented programming in chapter 12, which won't be probably for a good month or 2. All right, same with the key thing. I'm not going to talk about those right now. All right, so let's just quickly go over the overflow exception. I've mentioned this before. It's the old proverbial trying to shove 10 pounds into a 5-pound bag. So in other words, if I create something that I say is, let's just say, an integer value, which will hold a big number, like 9 billion something. But instead of, I reach the max. So let's say that that's 15 digits. And I put something in with 16 digits. Well, that's going to blow it out of the water, and I'll get an overflow exception. An out of memory exception, as it says, raised when the program does not get enough memory to execute the code. Stack overflow. All right, these are, most of the time, this stuff is stuff you don't have any control over. All right, and a timeout, well, a good example of a timeout, and again, we won't get to this till near the end of the semester, but you are trying to open a database, and that database is out on the internet someplace. If you don't know what a database is, don't worry about it. Imagine you're trying to open up something out in the internet, and you give the program 30 seconds. And if it can't open it up within 30 seconds, it times out. Then you could throw a timeout exception. All right, so it says, when an error occurs, either the application code or the default handler handles the exception. So all that stuff is explained in here. I'm not going to go over it. All right, but I did want to quickly mention the other things that I gave you here. This is another thing that's up here. And let me give you this. So this one right here, fantastic. All right, let's see, get rid of that. Is here at tutorialspoint.com C#. This is the second one of the URLs that I gave you. Why did I give you this? Because again, it explains in depth how we're going to do this stuff. We're going to look at the try block in just a few minutes. We're going to look at the catch block in just a few minutes. We're not going to use the finally block, but we'll talk about where it is, why it is, and how it's used. Plus, we're going to throw our own exceptions. But after we get through this, if what we're doing doesn't make a boatload of sense to you, this is another resource that you can take a look at to get some more information. All right, well, don't need that. Then next, I actually went out to the Microsoft documentation. And this is the overview right here, exceptions and exception handling. And the first thing that's underneath this is exception handling C# programming guide. So that's this right here, whereas this is the one right here. So you can see the stuff that's in there. All right. Now, why did I even show you this? Well, first of all, these are actual, supposedly, according to Microsoft, they're all working examples. But the other thing is, why not go to the source when you've got questions? All right. So if you want a lot of verbal documentation, you can go in here. All right. So like I said, I wanted to start with that because I wanted to at least show you what we'll be talking about today. All right. So as they mentioned in here then, it says, in the last 2 chapters, we learned how to make a future value app that calculates the future value of a series of monthly payments. However, if the users enter bad data, the exception occurred and the app will crash. In this chapter, you'll learn how to prevent that from happening by using exceptions and by validating data. Well, guess what? The stuff we've been writing, it's not going to crash because I've already been showing you most of the stuff in here on how to validate data. But they show it in a really nice way. You may or may not remember this. I talked about this a couple weeks ago. But every single control has what's called a tag element, T-A-G. We're going to look at the tag element. We're going to set that, and we're going to be able to write more generic routines. That's the last half of the chapter, rather. But let's get into talking about exceptions. And again, if you want all of the stuff in here, all of the textual stuff that's in here, hey, give this a read. There's nothing wrong with it. In fact, it's very well written. I have read it. But I want to jump into here. If you haven't seen this kind, if even in your own code, if you haven't had a statement that's come up yet like this, that it comes up green, you get the box here, and it comes up and it says, input string was not in the correct format. All I can tell you is you haven't been writing enough code. All right? And I'm just being serious. I'm not being facetious or funny or anything else. It happens to everybody. So in this case, notice we've got here decimal monthly investment equal convert to decimal txt monthly investment dot text. When is that going to blow up? It'll blow up if we put nothing in the text box. It'll blow up if we put something non-numeric in the text box. You've seen plenty of examples of this before. And again, previously, the way that we've always handled this is we do the try parse instead of doing the convert. That's a very good start as far as doing this. All right. And I want to tell you one last thing about this, and that is before I came in, or before we started the lecture today, I did go out to Google and I put in why use, you can see it in their C# exception handling. Why even use it? Believe me, you can see articles online that'll say, of the 3 ways that I told you, that using if statements and while loops is much better than exception handling. All right, so why use it? Well, one of the things that they mention in this article, and again, this is one of the ones I gave you, is it says C# provides a structured solution to exception handling in try-catch blocks. It says using these, the program statements are separated from the error handling statements. That is the biggest reason for using exceptions. Try to put that in English. It says you've got your actual code you want to try to execute in one place and your code to handle your errors in another place. All right. Now, there are people who say that's a good thing. There's other people who say you shouldn't separate them. There's all sorts of schools of thought on this. Virtually every programming language that I know has some form of try, catch, and finally. All right. And I don't know how many languages I know, but I will just tell you for certain, there's one in JavaScript. There's one in C#. There's one in Java. So, I mean, all the stuff that you will be covering in this program have try-catch statements in them with a finally. All right. So it says the exception hierarchy for 5 common exceptions. Today, we're going to talk about format. We're going to talk about arithmetic. We're going to talk about divide by 0. We're not going to talk about the overflow. But this is an extremely important picture for one reason. And that is, if I'm going to go and try to catch, I can catch, if I have a try statement, Do I need to have at least one catch statement? The answer is actually no. But if I put a try statement in there without any catches, it would be kind of silly, but I'd put a finally statement in there. That's almost never done. In fact, I've never seen that done in application code. But if you put in a try statement and you want to catch errors, all right, I have to list, please listen to this. I have to list the divide by zero exception before I list the arithmetic exception. So in other words, when I'm listing all of my exceptions, because I can catch any of those exceptions that I showed you earlier. So I can catch any of these right here. But there is a hierarchy to them, and I have to catch them, or when I catch them, I must catch the most specific errors first and the most general errors down at the bottom. All right? There is an exception that's called exception, which will handle anything that wasn't covered underneath it, that the language thinks is an exception. But if I am going to have in my program, let's just suppose for a minute, I'm going to have catch statements for all 5 of these exceptions. Then either this one or this one must come first. So let's say we do that one first and that one second. Then this one or this one must come third. So let's say we put that one, then that one, then that one, then that one. Finally, that one has to be last. Because again, the farther down you go down the exception hierarchy, the more specific the exception type is. And you want your more specific exceptions caught at the top. And think about why that's the case. Since all of these, since these two are children of this, and these two are children of this, then technically, looking at it in an ancestry way, these two things right here are grandchildren of this. If I did exception first, then I put the other ones, I'd never catch those because exception would find everything. So again, I'm sorry I made a short story long, but your most detailed exceptions must be put at the top. And as it goes down, if you're catching multiple exceptions, your more general ones go down further, and the most general one, if you do it, exception, must be the last one. All right, that's all I can say. Now, methods that might throw exceptions. Guess what? We've looked at these before. You've looked at virtually every one of these except the date time. All right, and they all work the same way. So these are the kind of exceptions they can throw. Format exceptions. So again, to 2 decimal, if I leave it blank, or if I were to put something non-numeric in it. An overflow, I don't know what the biggest number I can put in for a decimal is. We saw that in an earlier chapter, but let's say it's 26 digits. All right, so if I put in 27 digits, I'm going to get an overflow exception. Same thing with int, same thing with decimal. Notice that date time doesn't have an overflow, but it has a format exception. It expects stuff to be typically either in a month, day, year format or something similar to that. All right, so how to display a dialog box. Now, the example they give here, pardon my French, it sucks. We're going to come up with a better example in just a bit. I'm going to go through these entire first 10 or so pages talking about exceptions. Then I'm going to jump into and look at the code that I sent you. And then we're going to come back and we're going to look at validating data. Then we're going to jump back again into the code, just so you know. But to have an exception and just put in a message box that says, hey, something happened, that's not really doing very much. But it is legal to do this. All right. Now they're talking about message boxes right now as though they haven't been used yet. We've been using message boxes. You know that where it says, please enter a valid number, that's the text. And you know where it says entry error, that's the title. All right. And that's kind of what they're telling you in here. And it says in Chapter 6, you'll learn how to use the message box class to display more complex dialog boxes that, guess what? We've done that already. You already know how to add the buttons and you know how to add the icon. And that's what they're talking about in Chapter 10. All right. When I feel, right or wrong, when I feel that it's time to present something even if it's out of order from what's in the book, I'm going to do it. And I think that you all are bright enough that when I explained the message box.show when I did and showed you the things that were in it and we went over it 2 or 3 times in depth and breadth of coverage, that you get it. All right, so I'm on page 200 here. To prevent your apps from crashing due to runtime errors, you can write code that handles exceptions when they occur. Let's break these 2 sentences in here down. Let's look at the first one. Runtime errors are just that. They are errors that occur when the program is running. All right, one more time. They are errors that occur when the program is running. I think I turned this on, didn't I? Yes, I did. Good. All right. That's hence the name runtime. You don't know if you're writing that simple calculator program like we did. You don't know that the person's going to enter a number of 10 and for the first number and a number of 0 for the second number, and then press a divide button or choose a divide option until they do it. That's why it's a runtime error. So providing for runtime errors, as it says, this is known as structured exception handling, and it plays an important role in most applications. Again, the structured exception handling part goes back to what I mentioned before, and that is we are separating our actual program logic from the error handling when something goes wrong. And that's pretty much, I believe, it's my take on what they're talking about. All right, so this is the syntax for it right here. You put the word try in there. And inside, well, let's just look at this example. In this here, these are statements, any of which may fail. Any of those statements may fail. All right? If we go all the way through and we do this and it succeeds, 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 we totally skip the catch. But let's say that we do this and we left this blank, or we do what they did here. We put XX in here. So it tries to take what's in that text box, which is XX, and it tries to convert it to a decimal, which doesn't work. All right, so what happens is it jumps down immediately to the catch. This is piss poor programming that they put in here. Whenever you do a catch, you should tell the type of exception you're catching. You're going to see in all of my examples, I don't do it like this because it sucks. Pardon my French, but I'm just being honest with you. Why they're showing it to you like this, I have no idea. But I didn't write the book. All right, but if this fails, you come in here and you just put out a message box that says, please enter a valid number. All right, well, that's fine. What happens next? It depends on the rest of your code in here. But the point is this, inside of the try, the curly braces for the try, you put in one or more statements that can conceivably fail. If those statements, if that statement or those statements do not fail, whatever is in the catch is not executed. If a statement fails, you go down to the catch. All right, we're going to have multiple ones of these in some of the examples that we go through in just a bit. All right, so that was it in kind of in a nutshell. Now, what they don't show here is what you can put at the bottom is the word finally. Then in double quotes, you can put in, or not in double quotes, in curly braces, you can put in whatever you want. Almost always, when you use a finally statement, it's for what's referred to as housekeeping operations. So if you've got a database open, you close it. If you've got a file open, you close it. If there's something, see, if the try runs and it totally succeeds, you skip the catch, but if there's a finally, you do it anyway. If the try fails and you do the catch, you still do the finally. So the key thing about using finally is finally runs whether the try succeeds and the catch does not get executed, or whether the try fails and the catch gets executed. Regardless, the finally runs. And I think they'll talk about that a little bit later on in the chapter. All right. So when you get an exception, it has two main properties. One is a message, and that's the message that describes the exception. The other one is what's called a stack trace. So you can print that out and find out what called what called what, etc. So you can try to debug and see exactly where your program blew up. Now, in just for a second here, I'm going to jump back. I'm on 203. All right. This thing that you see right here where it says system.format.exception input string, the part here that says input string was not in a correct format. Those 1, 2, 3, 4, 5, 6, 7, 8 words, if I counted right. Those 8 words, input string was not in a correct format. That's the message. All right, so that's what you're going to see. Now, this down here, so there's the message, that's the stack trace. So it's telling you where, basically where it blew up, and then it's telling you, hey, before it blew up, this was called, before this was called, this was called, before this was called, this was called, etc. And when you look at this, it goes from the last to the first. So it's a LIFO thing, last in, first out type of thing. All right. And when you look at this, it's known as, at least I've heard it put this way, you're unwinding the program stack. And typically that's something that you're going to use when most of your other debug mechanisms fail. All right. So as it says here, if you want to use these properties, you must supply a name for the exception. All right. Notice they've changed this. They've just got exception E or EX. You can name this right here, this EX that they're showing there. You can name that anything you want. And you'll see that I've got my own way of naming things. You don't have to use that if you don't want to. All right. When I say you don't have to use my way of doing it, but you must give it a name. All right. If you're coding the try catch within an event handler, you can't use E for the name of the exception because it's used as the name of the parameter for the handler. So this, if we had put E in here, we'd get an error. All right. So how to catch specific types of exceptions. Now we're getting to the nitty-gritty, so to speak. So notice when we look down here, I'm going to just keep this up while I talk about this, okay? So notice, as I showed you before, we've got a format, then an overflow, then an exception, which means this one is more generic than this one is. All right, and this one either is more generic than that one or they're at the same level where the order wouldn't matter. So what we're saying here is multiple things can go wrong. All right. So if we go in here and we try to convert this and we can't convert it successfully, we'll get the format exception. So it'll come up and say a format exception has occurred. Please check all entries. All right, that'll be the text and the heading for it will be entry error. All right, and that'll happen if either this to decimal happens or that to decimal happens. All right. If we come in here for the years, and let's imagine that instead of an int, we use the word byte in there, B-Y-T-E. And the reason I'm saying that is byte only has a range of, I think it's negative 255 to positive, or negative 256 to positive 255. So let's say we made that a byte right there. And for years, we put in 100,000. Then we get an overflow exception. All right, just to explain that one to you. If anything else happened where the system said, something's tweaky, something's hinky here, we can't go on, then it would grab this exception. And you'll notice, regardless, so again, let's say that all of this stuff succeeds. Everything that's in here, that's in this try block succeeds. Then we totally skip all of the catches and we go to the finally. Let's suppose that the try block fails and it gives us a format exception. Then we do this and we jump down to the finally. Let's suppose we do it and we get an overflow exception. Then we skip the rest of this, we skip this, we do what's ever in here, and we go down to the finally. And to finish, if there's some kind of other weird exception that happens that's not in a format, it's not an overflow, it'll be caught with an exception. We'll do that and we'll do the finally. If you understand that, and that's what gets explained right here, there's nothing more to say. But in order to be able to understand this, and in order to be able to use this, you've got to see some code examples. And I think better ones than what they're showing there, where they've got message boxes. All right. Now, next thing is on how to throw an exception. Okay. You can throw an exception. You can. All right. Why would you want to throw an exception? Well, let's just talk about it for a minute. When you think about it, when we were doing our miles per gallon program, we said that the minimum number of gallons that you could use was 1 and the maximum was 100. So we checked for that using an if statement in our code. All right. And if that failed, if we put in a negative number or a number greater than 100, we set it to a default value. That's one way of handling it. Another way of handling it is what we could have said was, if the the gallons used was less than 0 or less than 1, I guess, or it was greater than 1,000, or using our constants, if we'd have said if gallons used less than min gals or gallons used greater than max gals, we could have thrown our own new exception. All right. In fact, in that case, we would have thrown an argument out of range exception, and then we could have handled it in our code. All right. You can throw your own exception that does basically anything. So I could throw an exception that would just say, hey, I don't like that, and I could catch it here and then handle it. All right. That's how you can throw your own made up exceptions. All right. Now remember, the exceptions that we have are these here. There is no exception here that says that there is no gallons used out of range exception, but there is an argument out of range exception. So that's the one I used. All right. I don't typically, when I do this, create my own brand new exceptions. I try to use, if possible, the ones that are given in here. I think that makes more sense. They're more generic. People know what they represent. All right. Okay. You can use a throw statement or a throw expression to throw a new or an existing exception. It says the throw became available in C#7. All right. And can be used in context where some throws can't. Well, let's see. There's an exception, and there they're doing it again. And this might look a little weird. All right. What this is saying here with the double equal sign is that says, hey, if for some reason the product code is null, then throw this. You can do it, instead of doing it the way they show it here, you can do it this way as well. All right, but you might see this in some newer code. Don't worry about that for right now if that doesn't make any sense. All right, then they go in and they add some exception handling to the future value. It's pretty much what we've already looked at. All right. So it is 8:48. No, I'm not giving you a break yet. I'm not that nice a person. But before we go into the how to validate data, I'm going to go in and I'm going to bring up what I sent you this morning, which is, and it's got a lot of junk in it. I'm sorry for that. I added stuff and removed stuff. So if you open up the actual solution file, all of the stuff in there, because it's been tested. Now, knowing my luck, it'll break today. But all of the stuff that's in there, and there's 1, 2, 3, 4, 5 programs, all of it should have been tested. This first one that's in here, this Calculator Console 1, is the one we looked at yesterday. All right? And it has no exception handling in it whatsoever. So if you remember, we've got this input number, and we could pass it a 1 or a 2. We were coming up with the idea in that we've got a generic routine that will handle inputting either the first number or the second number. But there's no exception handling in this whatsoever. And when we go down to the bottom, remember this, that when we went in here, we said, hey, so I added a little bit in here. If the second number, when we're doing either a divide or a modulus, if the second number is that, throw a brand new divide by 0 exception. Notice I put all this into a try block. It's the same exact code we had yesterday. The only thing I did was this before, when we did this, there was a write line that said illegal attempt to divide by 0. Now, instead of doing that, we put the whole thing inside of a try block. And if we do have a 0 denominator, we're throwing a new divide by 0 exception. And again, that exception, that divide by 0 exception, is one of the ones that's listed in here. If you click on that, it goes right to the page, and it goes right to the Microsoft documentation page, and it shows you an example. All right, so jump back. I'm going to throw that new exception. So I have to catch it. I have to handle it. And all I'm doing in here is just doing a write line. This is a real simple example. I didn't want to change up what we did previously very much. But one last time, the change that was made in here previously in this calculate and display quotient or modulus, we did not have a try statement. All right, so that was not here, and all of this was not there. So that was gone. The only other thing was the line right here that says throw new divide exception. The code for that, this code right there, was put in right here. So in other words, we handled it just fine, but we handled it without any exception handling. None. All right, you'll notice if you look down here, I have no errors, so everything's still clean. It all works just fine. But now if I come in here, I'm going to do a file save all, and I'm going to run it again. I think I already set my startup project, but I'm making sure. So if I come through here and I say 12 and I say 0 and it says enter the operation and I put that, it does exactly what it did before. Attempt to divide by 0, illegal attempt to divide by 0. Now, where it says attempted to divide by 0, all right, where is that? Notice a divide by 0 exception. I called mine DBZE, divide by 0 exception, all right? And I wrote the message. This message right here that you just saw, that message, that is attempted to divide by 0. The other thing that says illegal attempt to divide by 0 on a new line is what I wrote. So what I'm showing you here is we are now handling a divide by 0 error in our very simple console calculator. We are handling it by using some structured exception handling. All right, that's what I'm trying to show you. Plus, we are showing the system message, which is attempted to divide by 0, and our own message. We could show both those messages. We could show just one of those messages. Like, it doesn't matter. It's up to us. Heck, it's our program. So that's that one. So, as I oftentimes do, let me ask, any questions on that? Anything on that that does not make sense? All right, I don't remember if I put anything in here for the GUI one. Let me check. If I did not, we're going to jump right into the other one. I was running slow on or close on time today. So, all right, so that one I left as it is. If I have time, I'll go back and add some exception handling in there. Will I have time? Probably not. But if I do, all right, I'll go back and add something in there. Maybe I'll even try to do that during the breaks. All right, so I'm going to jump into then the, let's see. Did I put anything in the MPG console? I don't remember. I don't think I did in there. Yes, I did. All right, so this is the miles per gallon. All right, so notice, again, we've got a try block in here. And what are we doing in the try block? Well, we're coming in here and we're attempting to do what we did before. All right. Now notice if result, so this means if the parse failed, I'm throwing my own format exception. So if I come down here and it says input miles driven, I'm going to do this. If I leave it blank or I put in something non-numeric, this is what's going to be thrown. and this is what's going to be caught. All right, so you'll notice it's starting to get a little bit better. And what I mean is, notice that here is where I get a format exception. Then I come down to here. And I say if the miles driven was out of range, then I'm throwing an argument out of range exception. You may or may not remember from yesterday, but yesterday I had one big if statement that covered both of those. And I wrote a generic error message. Now, since it's two different conditions, in the first one that you see up there on lines 53 to 57, that's something illegally formatted. In lines 59 to 66, that's something that's out of range. So if it's illegally formatted, I'm going to do this. If it's out of range, I'm going to do this. Well, what's this? I'm writing out the system message, and then I'm calling this handle bad input miles driven. I'm letting it know the type of exception I had, and notice I'm passing in miles driven as a ref, which means I do want to still go in here and manually change this to my default. All right, so again, I'm going to say this again. I'm going to run through both of these situations. With the first one, I attempt to come in here and parse this. I'm taking for granted that by now you all understand what parsing is. Since this is a read line, I'm attempting to take whatever I read in from the keyboard, and I'm attempting to take it and parse it, convert it to a decimal, and I'm going to save it as miles driven. If that fails, which means the parsing failed, so again, either I left it blank or I put something in there that was non-numeric. If that's the case, I'm throwing a brand new format exception. So the code stops here and it jumps down and it looks for a format exception catch. It finds it right there. Catch format exception. Again, FE is what I called it. All right. And what am I doing? Well, I'm first going to write the message. So that'll say something like, this was input in the bad format. Then I'm going to call this routine. What's that routine? It's called handle bad miles driven input. So this format exception, that becomes this type right here. And our ref miles driven is what's here. So I'm going to write out here, format exception, illegal input, setting miles driven to a default value of 100. And that's when it's going to actually set it. On the other hand, I put a number in there, but I put in -6. So that the parse succeeds. So this I don't execute, but miles driven is less than 1. So again, just play computer. So since it is less than the minimum, I come in and I throw a new argument out of range exception. So it jumps down to here. It writes down the system message that says something along the lines of the argument entered was out of range. Then we call our own routine, and that argument out of range exception is what this is. So that's what's going to print here. And then again, I want to reset miles driven to a default value. All right, so let's save this and run it. Now, when I first run it here, I'm going to put in valid stuff, 346 miles. All right, 12 gallons. Oh, I didn't change my, let me do that. So this is my MPG console. I want to set that as my startup project, sorry. So I come in here, enter miles driven between 1 and 1,000, okay? 346 and 12. Everything's cool, not a problem. Hit enter. Now here's my next one. All right. So the first thing I'm going to do is just leave it blank. As one of the identified items was in an invalid format. Format exception, illegal input, setting miles driven, etc. So I want to take this and I want to shrink this down so you can see exactly where all this happened. All right. This was a format exception. All right. So where I wrote out fe.message, that's the one of the identified items was in an invalid format. So where you see that, one of the items, that's fe.message. Where the rest of it is, that's from the routine I wrote. So it says format exception is what it should say. All right, then on a new line, illegal input setting miles driven to default value of 100. And then we actually do it. All right. Then, as you'd probably guess, and we'll do this in a second, we do the exact same type of thing, but we do it with gallons. All right. So we first go in and we verify that we were able to do a parse. In other words, that this was a number, so we could parse it into a decimal. If that failed, we threw a new format exception. And what's different in here? Well, up here, I wrote a routine called handle bad miles driven input. And down here, I wrote handle bad gallons used input. But the ideas are very similar. Virtually, they're identical to one another. So if I have an invalid format, I come down to here. It's going to write the message, and it's going to say format exception, and it's going to reset that down here. Catch. Argument out of range, except down here, it's going to set that miles driven. In the same way, if I do put a number in, but that number is less than 1 or greater than 100, I'm going to throw a new argument out of range exception. All right, that's going to come down into here. And again, it's going to write the system message, then my own message. So it'll say argument out of range. Then it'll say illegal input setting gallons used to default value of 10. Let's verify that all that works. So we make this bigger again. So input gallons used, again, I'll put in hello. So again, you notice that the message we got for both of these, the system message for both types of exceptions said one of the identified items was in an invalid format. There and there. All right. Oh, I guess it's because they were both format exceptions. All right. So that's fine. Let's run it again. And let's get both of them. So I'm going to come in here and again, leave this blank. So there's my format exception. Now I'm going to put in something that's out of range. All right. So I'm going to put in -33. And you'll notice here was the system message for a format exception. And here was the system message for an argument out of range exception. So again, we've got the system message, then our own message, the system message, then our own message. Do you have to do that? I'm always of the mindset that if somebody is running your program, the more information you can give them, the better off they're going to be. The more it'll make sense to them, at least hopefully, the more it will make sense to them. All right? Now, I just threw a boatload of stuff at you. All right? And we did it pretty quickly. All right? And we did it faster than I thought we would. So before I give you a break, again, let me ask, at least conceptually, do the ideas make sense? Can I just hear a yes if conceptually it makes sense?
Yeah, it makes sense.
Okay, because this is the way you do it in virtually any kind of programming language. When you are in the, a year from now, when you are in the Android class, I'll show you how to do this in Java. It's done a little bit differently, but the ideas are virtually the same. There's an exception class, and underneath it, there's a bunch of different exceptions, or you can write your own. So this isn't going to go away. And again, you can do a similar type of thing to this. The try-catch finally happens, as I mentioned. We've got 3 languages in this program. You learn JavaScript in semester 1, and you use it a lot in semester 3. All right. You learn C# in semester 2, where you are right now, and you learn Android using Java in semester 4. And they all have the try-catch finally mechanism. So like I said, this isn't going away. All right. So I have only accounted on here. If I jump back into here, I have now shown you some examples of what? Of an argument out of range exception, a divide by zero exception, and a format exception. So those three. And again, some of the exceptions like index out of range, etc., aren't going to make sense until we get later on in the book. But again, what my goal here is to give you something, at least, that's going to start making sense to you. All right, and hopefully I succeeded in that. Now, I'm just going to go for about a minute or two. I'm going to give you your break a little early today. All right, your first break. But when we come back from the break, there's literally about 10 more pages in the chapter. And they talk about validation. And guess what they're going to talk about? All right. The first thing they say is, hey, make sure there's something entered into the text box. Excuse me. In other words, make sure it's not empty. Second, when you do a try parse, make sure that it succeeds. Third, check for ranges. Well, I think you'd all agree, or hopefully you all agree, we've done all that already. So we're going to kind of blaze through the first page or two of this quickly. But what they do then is they come in, they meaning Numerec, and where is it? They have written these three methods. Don't worry about writing them down, etc. You've already got them. I've already put them into the program. But this will allow us to pass in any field, any control, regardless of whether it's supposed to be numeric, non-numeric, whatever. This will handle all of our controls, and it'll check for something being present or not being present. This will handle any value that we put in that's a decimal type. All right. We could write another one for is in 32, another one for is double, etc. All right. We could do that as well. All right. And finally, this will be the new way that we handle ranges. Now, this is how they did it. They meaning, again, Numerec. And I am going to show you the way they did it, but we don't even have to make it as hard as they do. If we define global constants for minimum and maximum at the top, we don't have to pass those. I did do it and I passed them just to show you how they did it. But after we take the break, what I want to do is I want to spend probably 15 minutes to a half an hour going over this. Then I want to show you how I incorporated all three of those methods into the GUI version of the miles per gallon program. All right. And that, then we'll see where we are time-wise. If we're good for time, all right, then we'll start working on this stuff. We'll start on that today. And if we can, I don't think we can get all that done today, but if we can, hey, cool. Then tomorrow will be lab for the entire period, all 3 hours and 50 minutes. If we don't get it all done, I'll finish that tomorrow, and then the rest of the period will be lab. Hopefully what I just said to you made at least a little bit of sense. So I'm going to put in here 12-minute timer because I'm going to give you till 9:15. I will see you then. All right, the time is up, so I am going to continue on. And again, what I hope to do in this next hour here is to finish this chapter and also go through a fairly detailed example that will explain a lot of the concepts that are in here as well. All right. So how to validate data. As it says, when a user enters data, the data usually needs to be checked to make sure that it's valid. That's called data validation. When the entry is invalid, the app needs to what? It needs to do something. It says, display an error message and give the user another chance to enter data. That might be. This needs to be repeated until all entries in the form are valid. Now, this is as simple as, and Clayton, I don't know if you've ever used the actual machines that are in the labs at St. Louis or not, but whether you have or not, where I used to teach in Wisconsin, we had a lab. Students could use the machines there, but each one of them every morning had to log in. So they had a login and they had a password. And if they tried 3 different times and either got the wrong password 3 times or the wrong login 3 times, they got locked out for, I think it was a half an hour. All right. Well, that was a pretty terse form, but that was a form of data validation. All right. So as it says here, and we already looked at this kind of quickly before the break, it says it's common to perform 3 types of data validation, which we'll look at on the next page. First, if the application requires the user enter a value into a text box, you can check the text property and you can make sure that indeed there is something in it. Second, if the application requires that the user does, and it doesn't have to just be a number, remember it could be a date as well, but anything that you're trying to parse, you want to make sure it's of the expected value. Now that's normally going to be a number because you're going to do a decimal.try parse or a double.try parse or int.try parse, etc. Right? But again, it could be a date or something else. But you want to parse it to make sure it's of the right format. All right? And they're going to use that discard again in here. I don't typically do it like that, but it's actually a pretty good idea, and we'll talk about that in a minute. Finally, if you ask the user to put in some kind of a value, all right, and let's assume for a second, let's not think about numeric, all right? So let's say you were asked for your birth date, okay? And let's just assume you were born, today's your birthday and you were born in the year 2000. So you mean to come in there and put in 1/01/27/2000, something like that, all right? But you fat finger, instead of 2022, you put in 20,222. Well, you know as well as I do that would be a range check, all right? Another thing, for example, in range checks, the types of stuff that you see for dates, February has either 28 days or 29 if it's a leap year. What is it? January, March, May, July, August, October, and December, those 7 months have 31 days. On the other hand, April, June, September, and November, they have 30 days. Those are range checks that you can do, all right? Also, for instance, if you're asked something as simple as what we've done in the past for a test, we've done this. We've actually been doing range checking. If we had the minimum test score was 0 and the maximum test score was 100, we've already been doing that kind of range checking. All right. So they're going to use this, I believe, with the future value thing. So let's look. So there's checking for something being empty. Again, you don't have to do that, but I would always strongly encourage you put on the end of this a .trim paren, because not only then will that check it for blanks, but it used to be the reason that .trim became popular, and Michael, you probably heard me mention this last semester, but in case you didn't, and for the rest of you, it used to be that people would write forms, HTML forms, and they would make fields. They'd say this is a required field. But if somebody didn't want to enter something, they just hit the space bar once or twice. And sometimes that would suffice. So by using the trim, that's going to remove those extraneous spaces. All right. So again, there's our check for something being non-existent. Then, and notice I don't really do it the way that they do it. There's totally, what they've done is probably better than the way I've done it. Because I usually do the parse and then I put it immediately into a Boolean, then I check the Boolean. It's the same thing that they're doing here. Now, an important concept is this right here, this out where it says discard. Out means, literally out means that we are using that variable in this routine. We are giving it a value in this routine. Since we use the discard, that underscore, that means that technically we have to put a value in there because that's what the syntax of try parse says, but we're not doing anything with it. If we actually wanted to do something with that value, then we'd put it into something. For instance, we could put this into a variable that was called monthly investment if we wanted to use it later, for example. All right. And then finally, we've got our range check here. Now, I wouldn't have done it the way that they've done it. All right. I think this is extraneous code. I would have said if it's less than 0 or greater than 10,000, I would have said something like monthly investment out of range must be greater than 0 or less than. But again, that's what makes programming programming. All right. Different people look at how they're going to show errors in different ways. And you've also, you know, and hopefully this makes sense to you, you've got to consider the intellect of your audience. If I'm writing a program that I know is primarily going to be used by little kids, all right, then I want to make sure that the messages and stuff that are right are more simplistic. All right. Or maybe for older adults, you know, maybe for senior citizens. You want to make sure that you're very specific so they know exactly what it is they did wrong and exactly what they should do to rectify it. All right. So as it says here on the bottom of the page, data validation is when you enter data, you check it to make sure it's valid. When it's invalid, you need to handle it. The three types again are required entries, making sure that an entry is in a valid format, usually numeric, but it can be others, and making sure it's within a valid range. All right, and then they show how you can do all those, and it's what we just went over. Again, I'm just going to go on, and I'm taking for granted that what I'm going over here with you, if it does not make sense, you will ask. All right, so how to code generic methods for data validation. So they've got a method they want to make that's called isPresent. That's going to handle that first type of validation. It's going to check if something is there or it's not there. Then they're going to write one called isDecimal. All right, that's going to handle only checking for the valid, you know, a valid decimal. So if you're going to write these generic methods and you're going to have decimal and double and int, for example, you'd write 3 of them. Could you possibly write just one and put it, you know, basically pass in the type? You could. That would be probably more trouble than it would be worth. And it would make your code probably harder to understand. All right. And as they mentioned, once you understand how isDecimal works, you can code it for other ones. IsInt32, etc. And then finally, they've got an is within range. All right. Now, the key thing here for all these is all of them are written in a generic manner. Notice they're passing in a string and a string, a string and a string, a string and a string. And again, we're going to look at their example, but then I'm going to modify it because we didn't have to do everything they've done there. So let's look at each one of these. First of all, it's going to return a string. This message will either be empty, so it'll return virtually nothing, or that the name of the field, so let's say it was first name. Either if first name has something in it, it's going to return nothing, but if first name was left empty, it will say first name is a required field. So that'll be the error message. Now that should make sense, or hopefully it does to everybody. Okay, so it'll return a string. It's called isPresent. What are these two things? This first thing here is going to be the name of the text box you want to check, .text. This next one is something different. So let's look at it. So I'm going to jump into code for a moment, and I'm going to close this one, and I'm going to open up my MPG GUI 2. This is the one I finished right before class. I'm hoping it doesn't have any errors in it, but we'll find out. Now, this is exactly the same as the GUI 1 that we looked at yesterday. All right, the code is different, but there's also two more things that have been added. If I click in miles driven right here, and I go down and I find the tag property, I gave it a tag that's called miles driven. When you make your tags, just use camel casing like we've been doing. Don't use blank spaces. You're just asking for trouble. So that one's called miles driven, little M-I-L-E-S, capital D, little R-I-V-E-N. This one is called gallons used. That's its tag name. Little G-A-L-L-O-N-S, capital U, little S-E-D. Why am I going through the process of telling you that? Because what you'll notice, we'll go over the code in depth in a bit, but I just want you to see this, that when we're calling this, there's the text box, there's the tag for the text box. And that tag, I don't know what format it's in, but you must convert it to a string. All right, so it's the text box .tag .toString. All I'm trying to show you is that right there, these two things, the name of the text box and the name of the tag, are what is being shown here as value and name. And you've got value and name for all of them. So you're doing it, all of these are using the name of the text box, .text, and the tag. All right. So the next one here checks, and again, this is just checking for decimal. As I mentioned to you previously, if you wanted to check for an is double or an is date or an is int32, the recommendation would be make separate methods for each one of those. So again, it's returning a string. Its name is decimal. The value in there is the name of the text box .text. The name of the name is the name of the text box .tag .toString. All right. And again, same way that was set up before, in that we've got a blank message and we attempt to parse it. If the parse fails, that's the exclamation point there. So if this returns false, so if we tried to put in, if we had our field for miles per gallon, for miles driven, and we put hello in there, it should say miles driven must be a valid decimal value. If we put 346 in there, the if here fails and we just return the message. So the message will either be blank because this failed, or it'll start as blank. This stuff will be added to it, and then we'll return it. And again, hopefully that makes sense. And if it doesn't, you're going to ask. All right. So finally, we've got this one here, a method that checks for a valid numeric range. All right. And again, I use their names here. I'm not saying they're good names or bad names, but again, I was always taught that when something starts with is, it typically returns a Boolean. They're not returning a Boolean, they're returning a string. That doesn't mean what they did is wrong. That doesn't mean what they did is bad. It's just that, some of the lessons that I learned when I was your age were just literally beaten to my head, for lack of better words. So again, it's going to return a string. It's called is within range. This will be the name of the text box .text. This will be the name of the text box .tag .toString. This will be the minimal acceptable value. This will be the maximum acceptable value. Again, we come in here, and what are we doing? Well, first, we're again setting our message equal to the empty string. Then notice, because this is probably one of the first times we've seen this, we've got a nested if statement, meaning we have an if statement within an if statement. All right, we have an if statement within an if statement. All right? And if the first if is true, we do the inner if statement. If the first if statement is false, we skip the inner if statement. So we come in here and we attempt to parse whatever we passed in our text box. If it succeeds, then we do a range check. And if it's out of range, meaning it's less than the minimum allowable value or greater than the maximum allowable value, then we'll say the name, so something like miles driven, must be between 1 and 1,000, for example. As it says there, since it's common to check text boxes for valid data, it often makes sense to create generic methods like these for data validation. We could have had separate ones. We could have written our own validation method. For example, we could have had one, rather than the way we even did it, we could have had one that was called is first name present, is last name present, is miles driven present, is gallons used present. That would be a lot of duplicative code. And again, one of our tenets that we want to do in here is we want to not repeat ourselves when we don't have to. That's the dry principle. Do not repeat yourself. So we're writing a generic routine that in that case would handle all of them. If again, we assume that all of our numeric input is of type decimal, this will handle all of it, checking to make sure that it can parse correctly, regardless of what the name of the field is, because that's what we're passing in here, as long as we give it a tag value. All right. And then finally, the same kind of thing. Now, I was always just taught that, hey, at the top of your program, you set up your minimums and maximums, and you set them up as constants. And the reason for doing that is if they change, since you're putting all your constants up at the top of your program, if for some reason they change, all right, and imagine this, imagine we said the minimum number of hours you could work per week without getting overtime was 40. So you've seen me do this. Some of those of you who had me last semester, I'd make a constant called max non-OT, and I'd set it equal to 40. But what if the union comes in and complains and now it's 35? Well, by setting equal just at the top of the program to 40, I only have to go up to the top of the program and change it from 40 to 35, recompile, and now it's handled everything. That's typically why you set up constants. All right, so let's finish the rest of the chapter, then we'll look at some code. So how to validate multiple entries. All right, so what are they doing here? Well, they're calling all of these in here. All right, because it's possible. So we're calling it both for our investment, then we're calling it for our interest rate, and then we're calling it for our years. Now, if the is decimal failed, it's not going to check the within range. If the is decimal succeeded, you won't get an error message, but you will if the range is wrong. So what I'm saying is, you're either one of these is going to, either both of these will succeed, all right, or one will fail. But if one fails, if this one fails, right there, that one never gets done. If this one succeeds, if that one fails, you won't get a message for this one. If they both succeed, you'll get no message. So you'll notice in this case, for monthly investment, they put a non-decimal value. For yearly interest rate, they put a non-decimal value. And for number of years, they put in a non-integer value. All right. So as it says, you can use validation methods like those shown above for multiple entries. Then if the entries are invalid, you can make one dialog box that displays everything. Some people would find that a little bit intrusive and maybe a little bit hard. They'd rather have separate ones. All right, that's kind of what I've been showing you. All right, and then finally, to finish up this chapter, all right, they go back with a future value application and they add data validation to it. So you'll notice here, what did they do? They made the investment too large, they made the interest rate too big, and they left the years blank. So you can see the associated error messages that came up with that. All right. And then they just threw a regular exception, basically. And it just says an unknown exception occurred, and they also have a stack trace in here. All right. So the code is in here. I'm not going to go through it. I think that the ones that we'll look at are better than this, and there's nothing wrong with theirs. I don't mean to at all talk it down or anything. I just think that what I'm trying to show you, I came up with an example that I believe, at least in my humble opinion, does a better job of explaining this. So we're going to look at code, but before we do, I just want to mention, now, we're going to pretend for just a second it's a week from today. All right, where is that? Oh, I got so much junk in here, so there we go. So it's a week from today. What does that mean? That means we're going to go over Chapter 8. All right. Why is that important? Because you'll probably find Chapter 8 to be the hardest chapter we've gone over thus far. It's going to talk about arrays. I'm going to talk about them in much depth. All right. And I'm going to give you my own example that I've written. And I've written it twice to show you, for lack of better words, the old school way of doing things, and then more the new school way of doing things. All right. And then Friday, we'll go over Chapter 9, just so you have an idea of where we are, where we're going to, etc. So after tomorrow, I'm going to get rid of this, and I'm going to bring up this. All right. The array chapter is longer, a little bit longer. It's about 40 pages. All right, so it's longer than the ones we've been going over. 200, let's try 70. And then the next chapter is one of the easier ones, I believe, in the book, because it's going to talk about dates and times, and it's going to talk about strings. All right, I'll just hold off on that until we get to that point. All right, so with that said, let's go in and let's take a look at this second GUI program. And I want to go over it in some depth and breadth of coverage. And again, I'm telling you this, everything that I'm going over with you right now, you've got a copy of. What I emailed to you today was a new solution. I just copied the solution, but it's called, I don't know, Calculator 7 Me or something like that. Because originally I was going to have us do this together. All right. And maybe it would have been better to do that, but some of this stuff is so intense, it's so easy to screw it up and make a mistake. All right. So we're going to go over the miles per gallon program from the top now. So here are my constants, my minimum miles, my maximum miles. You'll notice there's no defaults. All right. Here's our miles, here's our gallons, and there's our MPG. All right, before I go over the button click, as we always do, there's our show message where we can write our own message box. There's our exit button, which we've been using. And here's our clear routine. And again, our clear routine is just clear, 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 focus. That's all it's doing. All right. So the thing to discuss in here is the calculate button. We're going to do that in a second, but what I'm going to do first is run it. So let me right mouse click on here and set that to make sure it's my startup project. So when I run this, it's going to look just the same as the one I ran yesterday. If you say I don't know what you mean, then please watch. Nothing. Miles driven empty. Miles driven cannot be empty. Non-numeric. Miles driven non-numeric. Miles driven cannot be non-numeric. And miles driven out of range. Miles driven out of range less than 1 or greater than 1,000. So we've got that one. Then if I put in a valid number, again, now it's gallons used empty. Cannot be empty. Gallons used non-numeric. It cannot be non-numeric. Gallons used out of range. less than 1 or greater than 100. And finally, it works. And again, I've got my cancel button and my accept button are working. All right, so I can hit enter there. Whoops, try it again. Get rid of that and hit enter. Let's try it again. Let's clear. And hit enter. That's working. Clear is working. It's center screen you can see already. And when I come over here and look quickly, I don't want to waste your time or mine. Tab order is 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, I'm taking for granted that stuff all makes sense to everybody by now. If it doesn't, then just send me a separate email if you're still having problems understanding what that stuff is. All right, so let's take this from the top. I tried to keep as much of what I had in here as possible, but still incorporate the new stuff. What do I mean by incorporate the new stuff? If I come down to the bottom here, well, looky there. Theirs is present, theirs is decimal, and theirs is within range. So it's all in there. All right, now in the book, I think we've done it the same way. I think I use the same names and everything, but let's just quickly look. So that was here. Make that smaller. All right. So static there. Theirs may have been static. Theirs may have been private. I was playing around with it a little bit. So let's make that private. Private string is present. String value name. String message. Check for blanks, etc. That's theirs. The next one is decimal. Again, when you look at it, it's the same. And finally, the is within range. And hard to see all of it, but there's theirs and there's mine. They're within range. All right. Okay. So let's take it from the top here. Play computer. So we come in here right from the top. All right. I've got this keep going thing. We've talked about that. So I'm calling validate miles driven. So that's the first thing we're going to do. So what are we doing here? Well, I made this new string called message. That message is going to be basically what's going to hold what we get back from is present or is decimal or is within range, just so you know. So I say message equal is present. Since message is of type string, is present must return a string. I'm passing it in the text box for miles driven. I'm passing it in the tag from the text box for miles driven, and I'm formatting that or converting that to a string. If this returns nothing, what does that mean? That means there was something in the text box. How do I know that there was if it returns nothing? Because when we come in here, if there's nothing in there, if there's something in there, in other words, if it's equal to nothing, so if it was left blank, we'll put something in there. But we set it to the empty string. If there was nothing, if there was a value in there, so I put, I don't know, for miles driven, I put in 10. It's not empty, so we're just going to return the empty string. Believe me, that came out sounding a lot better in my head than it did when I said it out loud. All right, so then I come down to here. And again, if it did not return, if message was not empty, that means it put in there something like miles driven cannot be empty. All right, or that was what it would put in there. So I just showed my own message. Okay, did I have to show my own message here? No, we could have shown the message someplace else inside of the routine we just called if we wanted to do that. All right, but I didn't want to do it that way. I just did it the way that I did it. And again, I think I've even mentioned this to you before. Occasionally I'll have people will say, you know, why did you do this way? Why did you do this way? And it sounds like a terrible answer, but usually what I'll tell them is, I did it that way because I did it that way. All right. I mean, sometimes we're just ingrained or we've got it in our psyche to do things in a certain way. All right. And That's the only answer I can give you. All right. So if message returned nothing, meaning we didn't have a message, all right, I could do a show message, and let's look in here. So here message has this in it. All right, so message actually holds that. So what I could have done is instead of saying this, show message gallons can be empty like that, I could have put in there message. Would have been totally fine. All right, I could have done that. And then instead of it having it say gallons used cannot be empty, it would instead use that whatever I got returned from there, which was gallons used is a required field. So that would be fine. We could have returned anything in here that we wanted to and either use something or not use something, or we could have made this a Boolean and said that it's called is present. And if there was nothing in there, we could have made it false. Otherwise, we could have made it true. So there's so many different ways that you can do this. But to try to keep kind of more in touch with what they've done, I'll change that. I'll change mine from miles driven here to I'll put message in there. Right? Not messagey, message. Then if we get down to here, just like before, there was something in miles driven. So now we're calling the is decimal. Again, we're passing it in the text box and the tag converted to a string. If that returns something, again, I'll come back and I'll put this in there as message. All right. And I'm, as always, I'm setting the value equal to nothing, and I'm setting the focus, and I'm setting my red val. If I get down to here, we've got a number in there. So now we're making our range check. Now, these two variables, I want to say this is the most important part of this. Those two variables were defined up at the top of the program. Since they were defined at the top of the program, which I think is a better policy, I don't need to pass them in. But doing that is now going to give me an error message. Why? Because it's expecting them to be passed in. It's expecting there to be a minimum and a maximum. I don't have those anymore, so I can do that. Now, where I've got min and max, all right, they have to be set to, min gallons or max gallons. Why didn't I do that? Because I want to use the within range for both, so I'm wrong. I should do it this way, the way they showed it. Because I want to make this generic. Here I'm calling it with miles. Here I'm calling it with gallons. So guess what? I foibled. I made a mistake. It should be just the way they've shown it here. Because we want this to be as generically written as possible. By making it more and more generic, it can handle, hopefully, if we've got 50 different values that we're putting in, and they're all decimal, we can handle all of them in here. But since I am giving a message here, I'm going to go back if I didn't do it already, and I'm going to say in here, so I've got message here and not in double quotes. I want the variable message there. All right. I've got message here, and I'll change this one to message as well. Now, what did that do? Well, I want to just show you. So now if I put nothing in there, I get the generic message. It still says miles driven, but it says is a required field. All right. If I make it non-numeric, it still says miles driven, but it says must be a valid decimal value. And finally, if I make it out of range, it says miles driven, and it says must be between. I did in here use, in my error message, I used the constants in there, and that's why. So it still works the same way as what I'm telling you. All right. Then I come down and do the exact same thing, but instead of doing it with miles driven, I'm doing it with gallons used. So again, that's message. That then becomes message. And that, I must have missed one, so there's one, there's that one, there it is. And that becomes message. So when I run it now, and I put a valid value in here, now gallons used is a required field. Gallons used must be a valid decimal value, and gallons used must be between those values. Now, there's a lot to be said about this and why this is actually important. Quite often, what you're going to want to have happen if you are creating an application either in-house or externally for somebody, they may want specific error messages, all right, where you might have to do some more tweaking inside of is present, or inside of is decimal, or inside of is within range, or in all of them, or any combination thereof. All right. What we're doing now by returning that message and using it is we are presenting an error message that is what? That is generic in nature. All right. You may think that's better. You may think that's worse. All right. But the bottom line is when you are creating something for someone, it's important that you get a list of requirements from them. Ideally, especially, and this, I'm just saying this now as it comes to me, but if you decide you're going to go out on your own and you're going to write, web pages and you're going to be a programmer, but you're going to be a contractual programmer, you want to make sure that if you agree to do something for someone, that you've got everything that's in there in the requirements, everything, you've got it put in writing. All right. Why? Tell you a very quick story. When I got my 2-year degree, I went to work at AT&T Bell Laboratories. That was back in the 80s before they split into just AT&T and et cetera and what they are now. All right, but the point is this. Now I totally lost my train of thought. It'll come back to me. The point is this, though. You want to go in, I know what it is. We agreed to, we had what were called RBOCs, which were regional bell operating companies. And we were creating a brand new feature. This is back in the days of rotary phones, all right, which some of you may have never even seen. But the point is, all right, we had agreed to create something for these people, and we had a thing for them. It was literally about a $25 million contract. So even with today's standards, not a small chunk of change. All right, we were about halfway done with it. And it was 6 weeks before we were supposed to cut it over. And we were at a meeting. I was out there at the meeting, and it was in New Jersey. And one of the people from one of these RBOCs, these regional bell operating companies, said, well, what about this? And we pulled the requirements out right in front of them and said, you never asked for that. It's not in here. They said, well, we need that. And we said, we can't give that to you in the 6 week time frame you want. We can't implement it, test it, et cetera, and get it ready. Then the guy said, and it amazed the hell out of me, he goes, then we don't want it. We said, you've already paid $12 million down. We don't care. We'll eat the $12 million. So right then and there, right on the spot, we agreed to add another requirement, but we got them to give us 6 more weeks to put it in. But there was one case where if we had had ambiguous requirements, all right, we could have been hosed. Tell you another quick thing real quick, and again, I'm sure you guys from last semester probably heard this one, but I had a student named Trevor, all right, when I was teaching in Wisconsin. Trevor's a great guy and one of the hardest workers I've ever had as a student. By his own admission, not one of the most talented, but he worked and worked and worked and worked and worked until he got things. Well, he had agreed to do a project where he was creating a website for a senior citizens home. All right. And one thing I learned from that was don't ever agree to do something for seniors unless you've got it 100% written down. We must have had a good dozen meetings with these people where we would go to the senior center and they kept saying, we want this, we want this, we want this. Finally, it got to the point where Trevor said, Mr. Scott, these are nice people. I like them. I've made some friendships with them, but I took everything that they've asked me to do so far, everything, and I've written it down and I put it kind of into a formal document and I added to that, all right, some space, and we're going to have a meeting with them this afternoon. I'm going to show them the requirements, what I've added, and I'm going to say, now, you can come up with more requirements right now. Whatever you tell me, I'll do, but I'm not doing anything more than that. So they came up with about 3 more things. He did those. We had one more meeting. And at the next meeting, they said, oh, we also want this. And Trevor said, you know what? I'll do them for you, but not for free. You had a list of requirements. You agreed to them. We signed it. You signed it. Now you want more. I'm sorry, but the free meter has run out. They were miffed. And they said, well, then fine, then just don't do it. And that's the last meeting we had with them. But we all learned a lesson right there, regardless of who your audience is, to have it written down. If you say to yourself, well, we got requirements for this and that, and they didn't ask for this, but they probably want it. If you go back and ask them, hey, did you want this too? Almost always, they're going to say, oh, yeah, we did. But if they didn't ask for it and you don't give it to them and they come back and go, you didn't do this, and you say, well, you didn't ask us to do that. All right, then a lot of times that's how you get future work. All right, because if they've written incomplete requirements, bottom line is it isn't your fault. Especially if you are, like I said, if you're a contractual employee, all right, because otherwise they're just going to keep piling stuff onto you and onto you and onto you. If you say, hey, did you want this? Of course we did. All right, okay, enough of the sermonizing. I'm taking for granted then, unless I hear otherwise, I'm taking for granted then that we are at the point where we have gone over everything that's in Chapter 7. You have at least a minimal understanding and comprehension of exception handling, what the try block is, what the catch block is, the finally, even though we haven't really done anything with that, what exceptions are, how to throw an exception, the basic C# exceptions that are provided. I'm taking for granted that you understand all of that, from the first half of the chapter. Also, I'm taking for granted that from the second half of the chapter, you understand how to validate, how to look for something being empty, how to look for something being formatted incorrectly, and how to look for something being out of range. Not only that, how to write generic methods so you can check for is present, you can check for is decimal, or you could change that if it was int or whatever, and you could write and understand an is within range. So I'm asking, are there any questions on that? And if I hear nothing, I'm going on. Any questions on anything we've covered thus far in Chapter 7? All right, then what I'm going to do is quickly, because I'm doing this, believe me, I'm probably going to make a mistake in what I'm about to show you, but I'd like you to follow along with me if you would, please. And that is, let me explain it, and then we're going to take a break fairly soon. All right, we're going to do 6-1, then we're going to do 7-1, then we're going to do 6-2, and then we're going to do 7-2. And I'm doing them from scratch. Why? Because I want them to look like theirs here. So that's what I'm going to write. All right. I think what I did is better and it looks better, but mine's going to look just like theirs, except I'm kind of anal that way. I'm going to make all these the same width, and I'm going to make a clear button in here, but I'm going to use that. I'm going to call this LBL operator 1, TXT operator 1, LBL operator, TXT operator, LBL operator 2, TXT operator 2, LBL result, TXT result, BTN calculate, I'll have a BTN clear and BTN exit. I'll set my tab order, and I will set my clear button and my accept button, and I will set the window screen basically whatever it is, the thing for Windows start position, I'll set that to center screen. All right. Then for the next one, very simple interface. I'm going to call this LBL taxable income, TXT taxable income, LBL income tax owed, TXT income tax owed, BTN calculate, I'll make a BTN clear, and BTN exit. And again, I will set the tab order, I will set the clear button, the accept button, the cancel button, and the Windows start position. All right. So what I'm going to do is I'm going to give you a break now. It is early, and I'm going to give you 20 minutes because I want 10 minutes to make this interface and 10 to make this one. I probably don't need that much time, but I'm going to give you that much time. I'd like you to do the same. I told you what I'm going to call things, and when we come back, I'm going to start writing code right away. Does anybody have any questions on what I'm asking you to do? All right, so then 20 minutes, I'm going to set up a timer. I'm going to change our timer to 20 minutes. And it starts now. Start taking your break, and please make your interfaces as well. I'm going to make a brand new thing. I'm just going to create a brand new folder that I'm just going to call it Chapter 7, period. All right. You want to watch? I guess you can watch me do it. I'll keep this stuff up here. So this is how I do these things because I find it easier like this. I'll use that one here and change that one.
Hello?
Yeah. Yes.
Okay.
We're on a break right now.
Is the same rule apply from last week? The assignment seems like you've already done. We don't have to do this week.
What's going to happen is I went over a bunch of programs this morning, which I sent to all of you. And I am going to do after the break, I am going to do 6.1, then I'm going to do 7.1, then I'm going to do 6.2, and then I'm going to do 7.2. So I've given them an extended break of 20 minutes so I can go in and build the interfaces for each of these and then get a small break myself. So after the break, that's what we're going to do.
Mr. Scott,
Yes.
do we have to turn this in as well?
No.
Okay.
Where is that? Come on. All right. Just finishing up the second interface here, so let me finish that and then we'll get going. Screen. That. Let me quick run this to make sure it works with what I've done. So, wrong one. All right. So I'm going to go back and just start thinking about writing code, but I want to look at the specs first. So let me go back to the first one, and I didn't name these well, but it'll work. So here's the first one. There it is. Okay, so got a bunch of stuff here. I want to close everything I've got and reopen stuff. No, that was okay. All right, so I'm going to open up the calculator. There it is. Now let's go back and take a look at what's in the book here. I'm going to do this very deliberately. In other words, I'm just going to do it the same way they show it in the book, other than, I use my own names for stuff. So let's see. All right, so 6.1. In this exercise, you'll create a form that accepts two operands and an operator. Okay, we've got all that. They said to call it, doesn't matter what you call it. All right, so we'll have these three variables in here. I'm just going to grab all those right now. All right, create an event handler for the click event of the calculate button, where you should enter the two numbers in the operand, call the calculate method, etc. Create a click event for the exit button that closes. That's already done. Create one that clears. That's already done. So I'm going to copy this, and I'm going to come back to my code here. And start putting in the code for the calculate button. Now I'm going to get errors here. Don't worry about it. I'm going to fix all those right now. So I'm going to have decimal operand 1. I'm going to set that equal to 0.00m. I've got that string for the operator. We'll set that equal to the empty string. And then we'll have another decimal for operand 2. All right. So those are my variables. I don't believe I'm not going to have anything in here that is, oops, operand 1, operator 2. That should just be operator. And it looks like operator is a keyword. I just made that operand. That's fine. All right, so that should all be okay. Now, let's see if we can actually do what they showed in the book. All right, so maybe I'll just combine these. I don't know, but I'm going to come in there and I'm going to grab that is present, that is within range, and that is decimal. I'm going to grab all those right now. Copy them to the clipboard. I just took them right out of the book. Okay. And I'm going to, so there's my clear. So here's my calculate. I'm going to put them all down here. All right. So let's see. We've got the is decimal. That'll work well. We've got the is present. That'll work. We don't really have a range in here, so I don't think I'm going to need this one. If I do need it later, I'll come back and put it in. All right. So got that stuff in there. All right. So the first thing I want to do is, and again, I'm going to do it very similar to the way they showed it in the book. So I'm going to come into here, and what do I want to check? Well, Operand One, I'm going to give it a tag of Operand One. Operator, I'm going to give that a tag of operator. Again, that was a key word. So I think I'm just going to call that operand. So I've got Operand One, operand, and Operand Two. Now that might be a little bit confusing, so I tell you what I'm going to do. Where this is, I'm not going to call it operand. For the tag, I'm just going to call it the operator. Okay, so I've got Operand One for a tag, the operator for a tag, and Operand Two for a tag. I don't need anything for the result. All right, so the first thing I want to do is, I mean, the order in which I do these, I guess, is up to me, but I want to check for is present in here. So I'm going to come in and do this. I'm going to say, again, the way they did it in the books, a string, MSG, and I'll set it equal to the empty string. I don't know if I need to do that or not, but I'm going to do that anyway. All right, and I'm just going to start. So I'm going to say validate. I'm going to call validate Operand One. Then when I get done, because it'll be almost the same, I'm going to call validate. We'll do the validate the operator, and I'm going to call validate operand. Now I'm going to do this in the guise of the way I've been doing things. So I'm going to put a Boolean in here that's going to be called keep going. And I'm going to set that equal to true. All right, so. Sorry, the older I get, the quirkier I'm getting about this stuff. So, all right, so if keep going. And I'm going to tell it in here again. I'm doing this all off the top of my head. There's a very good chance I'm going to miss something or make a mistake. Not on purpose, but I like to think at least I'm somewhat human. So validate Operand One. Okay. Else we'll just put in here return. And if keep going, validate operator 2, or validate the operator, I should say. And else, we'll fix all those errors in just a minute. Turn. All right, and then finally, I'm going to grab this one here. It's virtually the same thing. So validate Operand 2, else return. Finally, if keep going. And I'm just going to say perform calculation. Now I'm getting all these errors. You know this. All right. I'm getting all these errors because I haven't written those routines yet. All right. So let's see. This is going to be. All right. I know how to do this. So this will be validate Operand 1 or validate Operand 1. So I'm going to write that. So private bool validate Operand 1. For now, just so I get that error out of there, I'm just going to say return true. I'll change it in just a second. Now, that should be gone, except I want to say here, message, no, not message, okay, let's do that. Message equal, no, I don't want to do that. I want to say keep going equal. All right, so mine's going to be a little bit different. So, whoop, wrong one. There we go. All right, so I'm going to take this stuff right now, and I'm going to comment, oops, I'm going to comment all of it out. And as I write it, I will uncomment it. So the only thing I care about now is validate operand one. Okay? So I'm going to come into validate operand one here, and as I oftentimes do, all right, I'm going to set up a Boolean that I'm just going to call retval for return value, and I'm going to set it equal to true at the beginning. And then down here, that's what I'm going to return will be retval. Okay? Now, what do I want to do in here? I've got to do all of those validations. I've got to see if it's empty. I've got to see if it's numeric or not, and I've got to see if it is within range. But actually, just those two. There is no range, so I got to check those two things. So I'm going to make another string here that I'll call MSG for message and set it equal to the empty string. All right, again, very similar to what I've been doing. But now I'm going to come in here and say message. So MSG equals, again, I'm going to get an error, but I'm going to say, what did we call this? Is present, I believe it is, right? Yeah, right there, is present. So is present, and I have to pass in txt operand one dot text. I'll put it on 2 lines so you can see it, and then txt operand one dot tag dot toString. All right, and I'm going to do it the way they did it in there. I'm going to write the message right in there, and I'm going to say if message not equal to nothing, meaning that we had some kind of an error, I'm going to do 2 things. I'm going to say retval equal false. That's what I'm going to say for now, just retval equal false. I'll go over all of this when we get done. So retval equal false. Okay. Else, that means that there, well, let's start putting in a few comments here. Okay. Attempt to validate operand one for first, not empty, and second, can be parsed. Okay, so those are the 2 things I want to check. So there's the present, so that's the not empty. And I'll even put the names in here, so. And the other one was called is decimal. All right, so that's that. Now, this I'm not worried about. That error is going to go away in just a moment. So we've got that, retval, et cetera, et cetera. Okay, so if, then else. And I'm going to come in here and I'm going to put another if inside of here that says message equals, and now I'm going to call that other one that is decimal. And again, I'm going to pass in there txt operand one dot text, just like we did, and txt operand one dot tag dot toString. Okay, and that's going to handle that. All right, and again, just like we did here, I'm going to do that. So I'm going to say if the message had nothing in it, we're going to set retval to false. All right. If we get down to here, it already should be true, so we can just return it. We set it to true up here. Again, I'll go over all this in just a minute. I'm literally doing this off the top of my head right now. All right, so let's see. Looks like I forgot a paren there, which means I forgot it up above too, probably. No? Yep. All right, so 2, 2, 2, 2. Okay, that one's done. So now we have to do the operand. So right now I can go and uncomment stuff for validating operand 2. So this still has to be commented out, but this can now be uncommented, and this has to be commented out. Okay. So right now I should be okay with my validate operand 1, and I should be okay on my validate, so that's this one, and I should be okay on my validate operand 2. I'm going to grab the same comment I put here. And just change that to a 2. All right. Now I've got to validate the operand. All right, which I call validate the operator. Okay. So probably could just copy this, and I guess I will try to make it simpler. And now I'm going to do that one. So attempt to validate operator, the operator for not empty and holds valid operation. That I'm going to have to write a new thing for. And we'll call that is valid operator. We'll write that in just a couple minutes. All right. So this is validate the operator. All right, that's that. All right, red fail, etc. is present. So this will be txt operator, operator.text. And that'll be the same. That'll be handled. Now this, no, we don't want to say is decimal. We want to write something we haven't written yet, which is called is valid operator. And again, we'll pass it that stuff. We'll get that fixed in just a second. So we've got the is present. We've got the is decimal. Copy that. And I'm going to do an is valid operator. All right, so this is going to change, and I'm going to say if value is not equal to, and I'm just going to put in one for each one of the signs, a plus sign, and I'm just going to I'm going to do a bunch of copying here. And it's not a minus sign. And it's not a multiply sign. And it's not a divide sign. And it's not and I don't need that anymore, modulo sign. If it's none of those, must be a, oops, that should have been 1B, must be a valid operator. And I'll even put them in here. So plus, minus, multiply, divide, or modulus. Get rid of that at the end where I've got that. So now I can uncomment this. I did that really quickly, and my explanation will be a lot longer. All right. And then we'll write the perform calculation in a minute, but let's see right now what it looks like. There might be errors in it. Like I said, I was going to do this tonight and then do it with you tomorrow. So Oh, wrong one. All right. So there's nothing in Operand One. Well, doesn't like something. Okay, well, that isn't working. So let's go back and take a look from the top. All right. So I've got Operand One, I've got Operand Two, etc. If keep going equal validate Operand One. Let's start there. All right. Attempt to validate Operand One for it not empty. All right, and can be parsed. So we're coming in here and we're calling is present Operand One. Double check the obvious things. There is a tag in there and it is Operand One. All right. In fact, let me do a file save all. There we go. All right. So it's not present. So is present right here. Should be calling this. Okay. The value should be the text box. The name should be our tag name. Okay. If there was nothing put in there, it should be saying this. The name that we passed in, that name is a required field, and it should be returning the message. All right. In fact, now, since I'm going to print it out right in here, I am going to make this the way I think it should be written. I'm going to make that a bool. That's what the problem is. All right. And here, I'm going to do bool retval equal true. And down here, I'm going to set retval equal to false. I think this is why it wasn't running to begin with. And I'll make this retval. All right. Again, I'm going to go back. What doesn't it like here? Message equals. Not convert bool to string. Oh, okay. Okay. Now, I am going to go back out. Yeah, this is going to give me a bunch of errors now, but that's okay. I'm going to go back to here and uncomment everything after doing the validate Operand One, all of that stuff. So this is all going to be commented out now. That's the way I should have done it to begin with. And then I'll go back and explain everything if it works. So, showing me an error. Operator. Okay, that fixed those. Let's see. Fix those. The rest are all warnings, so I should be okay. And hopefully we can fix those warnings in just a bit. So there's nothing in there. Doggone it. This is the problem, like I told you, when you write stuff on the fly like this. That's why I don't like doing it. But hey, at least you get to see me in my element. So let's see. Keep going equals validate Operand One. All right. Validate Operand One. Boolean retval. Retval is present. So here, if it was something in there, it's set retval equal to false. Okay. And calling this. So we said if it returned false, so if not retval, then we want to set it to false. Otherwise, it should have returned true. So we're now going to say retval equals this. And again, if not, retval, we'll fix this in just a minute. All right, that should fix almost all of it. So where's our is decimal? That'll have to be a bool. Almost finished. And I'm going to be able to clean this thing up quite a bit in just a second. So, all right, try it again. Nothing in there. Son of a gun. Well, I'm just going to take it from the top here. Alrighty. Actually, I don't need this anymore because I'm either going to be returning true or I'm going to return false. So I don't really need that. Or this. You know what? This is what I'm gonna do. I'm gonna write all these and we're gonna start with this tomorrow. Okay? I don't want to waste your time. You're gonna watch me sit there and debug. Maybe you find some humor in that. I do. If I can't laugh at myself, how can I take it when others laugh at me? So what I'm gonna do is I'm gonna just call it a period right now at 10:48. And what I'd like you to try to do for tomorrow, we'll do it together. All right? In fact, what I think I'll do is I'm just going to get rid of all the code I have. I'll make a copy of this, but I'm just going to go back and start from just having the interface here, and then I'm going to add whatever is in here. Then I'm going to go down to here, and I'm going to add that stuff. All right. Then I'm going to go and have just the interface in here and do all of that stuff. And then I'm going to jump down and do that. All right. So I will go through tomorrow with you, starting tomorrow morning. We should be able to do that. And you should have, at most, it should take an hour to do each one of these, even with explanation. So my hope is by 10 at the latest, tomorrow we'll be done. You get 1 hour today to work on this, technically of class time, and you get 2 hours to work on it tomorrow. And again, according to our schedule, Monday is also lab ball period. So you can't say, hopefully you can't say, you haven't had any time to work on this. 1 hour today, 2 hours tomorrow will be 3, and 3 hours and 50 minutes, so just about 7 hours. Again, I will write the pretest this weekend, hand that out on Tuesday, go over it on Tuesday, and I'm also going to write the hands-on test over the weekend. Now, sorry I screwed that up in front of you. I have proven what I've known all along is I shouldn't do that in front of people. But that said, does anybody have any questions other than the last 10 or 15 minutes of class? Any questions on anything we went over today in Chapter 7? All right, hearing none then, I'm going to call it a period. And what I would like you to do then is please for tomorrow, make those interfaces. And I will say this one last time, just so you see it, because these are the names I'm going to use. So if you plan on coding along with me, which I think is a great exercise, you may or may not agree, but that's okay. So I call this LBL Operand One, TXT Operand One, LBL Operand Two, TXT, or LBL Operator, TXT Operator, LBL Operator 2, TXT Operator 2, LBL Result, TXT Result, BTN Calculate, BTN Clear, and BTN Exit. Just so you can see all of those, they're right there. So if you need to, you can always take like a screenshot of that. But I want, it'll probably be easier for you if you use the same names that I used. All right. And then finally, looking at the other one, I just finished that right as the thing was beeping. So hopefully those are all okay, but we'll find out right now. So I call these, again, BTN Calculate, BTN Clear, BTN Exit, LBL Taxable Income, TXT Taxable Income, Where is that one? TXT. Yeah. LBL, income tax owed, and TXT, income tax owed. As far as the setup for both or for each one of those, for the income tax and the calculator, any questions on that? All right, then it is 10:52, and I will stop it right here. We will pick it up
Mr.
tomorrow.
Scott?
Go ahead.
Okay, so yesterday I was doing the Chapter 5 Part 2 lab, and
Okay.
so on the first question, it's the test scores. So it says, please enter a test score in the box, like in your one text box, and then when you hit enter, you got like you're supposed to get like put like three numbers in the text box. Like, how do you put like multiple numbers in the text box and then like pull them from that text box, basically?
So you're saying like in here, how do you put three different values in?
Yeah.
All right. The only way that you could do that, all right, would be to write code that we haven't talked about yet. I would just put a number in there, or you can do it two ways. You can put a number in there, and I guess you could probably use a timer and have that number disappear, but that's not a good. I would put in three text boxes for now.
Okay. And
Even
then,
if it doesn't say that, that's still fine.
okay, and then for the vowels one, it says hint use a switch statement for this one. Like, so I guess like we use the switch statement to like count exactly how many vowels it is.
Well,
Like,
you'd
your
want
phrase.
you'd want to do something like this. All right, either. So if you want to switch, you want to do a switch on whatever the letter you're looking at. Does that make sense?
Yeah.
So you want to switch on the letter. All right. And then you can either say case A, case A, like that. And if that's the case, all right. Or you can do a two upper. So you could do a switch letter dot to upper. So you only have to check for uppercase. Does that make sense?
Yeah.
And then you could say case A, case E, I, O, and U. So if that's the case, no pun intended there, but if that's the case, all right, I would have some kind of a variable that I created that was called vowel count, and I just say plus plus vowel count, all right, and then for the default, which means it's a consonant, I would just break. Am I answering your question?
Yes.
Okay, I mean, because if I'm not, I just want to know what the question is. So you can do
No,
it like
that was my question.
Okay, you can do it like that and convert it, or you can make make 5 more cases in here with the lower case ones. All right,
Okay.
either way is fine. I mean, I think it's better to do it like this because this is one line of code, plus you've got that in there anyway, and it results in 5 lines. Otherwise, you're making 10 checks, which I think is kind of ridiculous.
Okay, and my last question
Sure.
is for for the last one. It's a console app to do like the rows and the columns. So it's like, I guess, will we put it in like how many rows and columns you want, and then it's like a multiplication table is basically what we're doing?
Yes.
Okay.
Yes, you're going to end up doing that as a for loop, basically. And you'll probably end up even doing it as a for loop within a for loop because you want to be counting both. You want to create your columns and your rows, or your rows and your columns. Does that make sense?
Yeah, and then so I guess like after we enter like how many rows and columns you want, and you hit enter, like it prints it out. Like, how exactly will we get like all the like the dots on there, or is it just like we'll just do it?
You'd either have to manually go in there and do it, or I mean, what you're going to have in here is something like this: for I equals 0, I equals num rows plus plus I, and again, that'll do all your rows. Then inside of here, you'll have like a for j equals 0, j equals the number of columns, plus plus j, All right, and that'll do the columns. So for each row, that'll do the columns inside of the rows. All right, so you'll need another thing in here. Then in here, you'll have to do the calculations and any formatting. Does that make sense?
Yeah.
Don't worry if it's not pretty. I don't really care. Again, I'm more concerned with, does the logic make sense to you as far as what you're doing?
Okay. Okay.
Okay? Anybody else? Either do you have any questions or other ones, or does anybody else have any questions? All right, 10:58, so you got almost an hour today. I will talk to you tomorrow then at 8:05. Have a good rest of the day. See you then.